Okay. Do you see my screen?
Yes.
So what is question 4, you said, right? So it says that, question 4, it says that sine of theta equals to 4/5, and theta is in the first quadrant. Find the value of sine of theta plus pi/6. So here the only point is, when it says sine theta is equal to 4/5, we want to find cos theta, okay? And we are going to use that theta is in the second quadrant. So let's first compute cos theta. So we know that sine theta square plus cos theta square is 1, right? So cos square of theta is equal to 1 minus sine square of theta. So that means cos square of theta is equal to 1 minus 16/25, which is 9/25. So that means cos theta. So what is cos theta then? So here there are two possibilities. Either it's plus or minus. But because theta is in the second quadrant, in the first quadrant, cosine is positive. So cosine is positive square root of 9/25, which is 3/5. And the reason is because theta is in the first quadrant. So that means sine of theta plus pi/6 is sine theta times cosine of pi/6 plus cos theta sine of pi/6. So this is 4/5 times root 3/2 plus 3/5 times 1. Now try to do the same question. Given that, let's modify it a little bit. What if theta is in the second quadrant? What if theta is in second quadrant? Cosine would be negative 3/5. Clear? These are the only two possibilities, right? Now question, you said another question? Which one? 5. It says angles A and B are in the quadrant 2. Okay, it's the same thing. So A and B are in second quadrant. And sine A is equal to 3/4 cosine B equal to minus 3/5. So we have to find cosine A and sine B. So we know that cosine A square is equal to 1 minus sine square A. So cosine A square is 1 minus 9 over 16. So cosine square is 7 over 16, right? Now, again, there are two possibilities, plus or minus. But because they are in the second quadrant, cosine is negative. So cosine A is negative root 7 over 16. And for B, you do the same thing. So sine square B is 1 minus cos square. So sine square B is 1 minus 9 over 25. So sine square B is 16 over 25. So sine B. Now, what is sine B here? Can you tell me?
Positive.
Positive. So it's 4 over 5. So that is sine. So we have everything. We have sine A, cosine A, sine B, cosine B. Now you can use this formula to compute cosine of A minus B. That's it. Just plug in the numbers. Any other questions? So the only thing that I just want to, maybe I have told you, but it doesn't hurt if I remind you, is that about the domain and range of trigonometric functions. For sine and cosine, the domain is all numbers, but the range is between -1 and 1. So this is very important. So in your test or in assignment, if you get some answer like this, sine theta is equal to 5 over 3, this must be wrong. Yeah, sine cannot exceed 1. Okay, this is definitely wrong. So that means you got the wrong answer. Okay, so f of x equal to sine or cosine so the domain for both is all real numbers, and the range for both, again, is the interval between -1 to 1. How about tangent and cotangent? Tangent and cotangent, you should be careful about the domain. For tangent, tangent has vertical asymptotes at x equal to pi half, minus pi half, 3 pi half, and so on. So the domain of tangent is all numbers except, or maybe I can just write like this, is the set of all numbers except that x cannot be equal to 2k plus 1 times pi half for any integer. So x cannot be 2k plus 1 times pi half. Means the odd multiples of pi half. 1 pi half, 3 pi half, 5 pi half, 7 pi half, and so on. That is the domain for tangent. And these are the vertical asymptotes. X equal to 2k plus 1 times pi half. These are the vertical asymptotes. And tangent goes like this. On each, between any two vertical asymptotes, it goes like this. How about cotangent? Cotangent's quite similar, except that the vertical asymptotes are all multiples of pi. So the domain of cotangent, and by the way, the range of tangent is all real numbers. I didn't write it here. Just let me just, range of f is all real numbers. So for tangent, it's obvious from the picture, it covers all real numbers. Actually, infinitely many times. How about cotangent? The domain is all numbers except integer multiples of k, the pi. And range again is all real numbers. But cotangent goes like this. Cotangent of pi half is 0. So x equal to pi half is basically the vertical asymptotes of cotangent. Oh, sorry, x equal to k times pi. These are, the blue lines are x equal to all multiples of pi, like pi, 2 pi, 3 pi, and so on. It's also good to understand, look at secant. So f of x equal to secant of x. So here the domain is the same as the domain for tangent. So the domain of f is similar to the domain of tangent, consists of all real numbers except the odd multiples of pi, pi half. So x is anything but the odd multiples of pi half. On here, the range is tricky. So the range for secant, and I will show you the graph in a second. So the range of f is all numbers less than 1, less than -1, union with all numbers greater than 1. So that means secant cannot cover the interval between 1 and -1, the open interval between. So it covers everything except the numbers between -1 and 1. So secant, for example, cannot be 0. Secant cannot be 1/2. Secant cannot be -1/3, right? So secant of theta cannot be 0. It cannot be 1/2, -1/3 or so. Let me show you the graph for secant. So again, you have vertical asymptotes, which are odd multiples of pi-half, like pi-half, 3 pi-half, and so on. And secant goes like this. I mean, that's fine. It's enough. But this repeats again and again. Yeah.
Why the domain is x can only go to 2k plus 1?
Because secant is 1/cosine. Right? Secant is 1/cosine. So that means cosine, the denominator cannot be 0, right? So now what values of x the denominator is 0? If x equals pi-half, 3 pi-half. Cosine is 0 when x equal to pi-half, 3 pi-half, and so, right? Is that clear? You see here, the range is anything but the interval -1 and 1. So this interval between -1 and 1, it's not covered in the range of secant. Okay, so that means the range is everything except this interval between -1 and 1.
What is the 2k plus 1?
2k plus 1? Like 1, 3, 5, 7. Odd numbers. Right? Odd numbers, like 1, 3, k is integer. So if k is 0, then you get 1. If k is 1, you get 3. If k is 2, you get 5. And so on. Now, if I ask you find the, so we can change something. So for example, find the domain and range. Let's find the domain. That is one question. Find the domain of f of x equal to tangent of 5x plus 1 be f of x equal to tangent of. Can you do this? So what is each of you? I want you to do this. So your exercise. You did? Diana? Did you do the question? You're good. So for example, for one, part A, so we know that the domain is anything except that, so 5x plus 1 cannot be equal to So that means 5x plus 1 cannot, or maybe 5x cannot be equal to 2k plus 1 pi half minus 1. So that means x cannot be equal to 2k plus 1 over 5, or maybe 2k plus 1 times pi over 10. So all numbers except these guys, which are basically odd multiples of pi over 10 minus 1 over 5. I divided by 5, yes.
So 2k plus 1, you divide that by 5?
Yes. You get pi over 10. Right?
Why is 2k plus 1 equals pi?
Because 1 over 2 times 1 over 5 is 1 over 10.
So that over 10 is also for 2k plus 1.
Yeah, you divide, it doesn't matter.
Also, everything's not by 10.
Yes.
Okay, but only pi over 10.
No. So, I mean, what is the difference? When you, for example, say 100 times pi over 10, it's the same as 100 divided by 10 times pi. So look, here, you have all numbers except these guys. For example, let me write a few of them. So x, for example, cannot be equal to pi over 10. So odd multiples of pi over 10 minus 1 over 5. And so on. Now do B, and be careful that here x cannot be also, x cannot be less than 3. So there are two restrictions. X must be greater than or equal to 3, and this square root cannot be equal to multiple of pi half, odd multiples of pi half. E. Who got the answer? I'll give you 10 seconds. 8. 9. Let's see. So we know that first of all, you have tangent of square root of x minus 3. So first of all, x must be, there are two restrictions, greater than 3 also, we have square root of x minus 3 cannot be equal to 2k plus 1. That means x minus 3 cannot be equal to 2k plus 1 square y square over 4. It means x cannot be equal to 2k plus 1 square pi over. So first of all, it has to be greater than 3. Greater than 3. So there are two restrictions. One is x greater than 3 or equal, and it cannot be equal to these numbers. So for example, x cannot be equal when k is 1, k is 0, then you get pi squared over 4 plus 3. When k is 1, you get what? 9 pi squared over 4. When k is 2, you get 5/25. And so.
So if I want to just find the root from here, I can use this formula to find the root.
That's the general formula, yes. Here are just some samples, a few of these points I want to show you. Okay. And maybe just a few questions about the range. These are very good tea that we have, but it's expensive for Starbucks. Starbucks. Yes, I used to. I was addicted actually. Very, very bad addiction. Now I convert tea. So for the first part, what is the range?
This is the
Alex, tell me.
x is the bigger or equal to
Why?
y.
Or, okay,
Okay.
yeah.
Y is bigger and equal to -7
Uh-huh.
and small or equal to the -23.
-7?
So the y is the bigger or bigger or equal to the -23, and y is and also y is smaller and equal to -17.
So -10 plus 3, it's 3. Be careful. So the range is basically -10 is fixed, right? Look, guys, -10 is there. And cosine is between -1 and 1, right? So 3 times cosine is between -3 to 3. 3 times cosine is between -3 to 3. Now you subtract 10. -3 to 3, you subtract 10, you get -13, -7. Right? So 3 cos, look. 3 cosine x is between 3 and -3. Now you add -10 to this side. So that means 3 cos -10 is less than 3 minus 10, bigger than -3 minus 10. So that means the maximum of this function is -7. Its minimum is -13. What is the range for B? Michelle. B is a little bit more complex because you have sine square. So we know that sine is between -1 and 1, but sine square, exactly, it cannot be negative. So sine square, so for B, we know that sine x is between -1 and 1. But sine square of x is greater than 0, right? And it cannot be greater than 1. Because if you square a number less than 1, you get a number less than 1. So now you have 2 times sine square. So 2 times sine square is between 0 and 2. And then 2 times sine square x plus 1 is between 1 and 3.
So we can just find the maximum.
I mean, yes and no, it's the same thing. But there are other techniques to find the maximum and minimum values, which you will learn in calculus soon. Coming soon. Okay, so why 0? Because sine square cannot be negative, right?
So it has to be one.
Hmm?
Just sine is -1 and 1.
Between -1 and 1, yes.
Just square, so 1 square has to be greater than 1.
So if you square a negative number, you get a positive number, right? So the range is, what is the range for this guy? So for this function, f of x equal to 2 times sine square x plus 1, the range is interval between 1 and 3. So anyone, part C, you get a prize. Small prize for part C.
What's the range for secant?
Secant is greater than 1, less than negative 1.
Greater or equal?
Equal, yeah. It could be 1 and negative.
Greater than 1. What's the other one?
Less than or equal to negative 1. Less than negative 1. Another prize for someone who can catch this fly. Okay? You got the prize?
I don't know, I'll try. So it's greater or equal to 2, than 2, and then less or equal than negative 4.
Perfect. You got the prize.
So what's the price?
Chocolate. I will get your chocolate. Okay, so secant x. Look, so f of x equal to 3 times secant x minus 1. So we know that secant x is either greater than 1 or less than negative. If you multiply by 3, it's greater than 3. So that means 3 times secant minus 1 is greater than 2. So that means the range is all numbers less than negative 4 equal union with all numbers greater than 2. Is it clear, Michelle? Okay. Okay, so we are almost done. I mean, we are really done. Almost really done.
Almost.
Yeah.
What
because it's like a sea, very,
Wow.
very endless ocean. It's very hard to get to the bottom of the depth of the ocean, like Titanic.
The lesson or?
Why the hell did he not bring extra pain control? They should have brought a wired one, not Bluetooth. It was running Windows. Windows is horrible for Bluetooth.
I don't know. Okay, so let's go. I want to begin. Do you want anything to discuss about trigonometry? Because I want to begin a new topic. Good. Huh? For the price? Yeah. Is a big price. Bigger than the math price. Okay. Let's continue. I mean, I want to begin actually a new topic. So we want to, this is called the operations with functions. And basically is when you have two functions, so here the lesson is when you have two functions, you can use these two to build new functions out of the two. For example, you can add two functions to get a new one. You can subtract two functions. You can multiply. You can divide. And you can compose. This is a new one, composition of function. Okay? So we have like similar to numbers, but for numbers, you don't have composition of numbers. You cannot compose to numbers. So basically constructing new functions. So if you have f and g, we can do so one. We can add, as I said, you can define the new function h of x, which is f of x plus g of x. Or you can subtract. You can multiply. And you can divide. So for each of these types of operations, so here you do, we introduced 4 types of operations: addition, subtraction, multiplication, and division. And for each of these type of construction, operation, I mean the value of h at any point, for example, for first one, the value of h at any point is equal to the value of f at that point plus the value of g at that point. Or for multiplication, the value of h at x is the value of f at x times the value of g at x. Okay, so basically what we do here, we multiply, add, subtract, divide the values. So another new construction is composition. And here is the picture I want you to keep in your mind. So you have two functions. Imagine that you have f and g. Let's say f of x equal to x squared plus 1. And let's say that g of x equal to two x. So you begin with some number, let's say x equal to 1. First, f acts. So what would be the output when f acts on 1? So when the input of f is 1, what is its output? 1 squared plus 1 is 2. So f takes 1 to 2. You can imagine a function like a map. It takes 1 to 2, like a mapping. How about g? Now, immediately after the action of f, g acts. So g, and then g takes 2 to 4. So that means here we have g o f of 1 equal to 4. Joe? Oh, Joe. So because first f acts, you have to write it on the right. Just next to 1. And then you write g. So you write f just next to 1, and then you write g. But in the picture, you see first f, and then g. So you make sure you understand what's going on here. Okay. Another thing. So what if x equal to 3? So f takes 3 to 10, right? And then g immediately acts on 10, you get 20. So then we say g o f of 3 is equal to 20. You finished?
Mostly.
Okay, you can submit. I mean, here we do it this. You can do g first if you want. But no, it's not the same. That's a very good point. When you switch, you might get different things. I will do that. That's a good question. So in general, so when I say GOF, so GOF of X in general, this is the definition. GOF of X is equal to G of F of X. So for example, GOF of 1 is G of F of 1, but F of 1 is 2, so it's G of 2, it's 4. Or GOF of 3 is G of F of 3. So F of 3 is 10, so it's G of 10 equal to 20. Is this picture clear for everyone? Okay, now we can also find actually a general formula for G of F. Once you have formula for G and F, so as I said, so what is F of X? F of X is X squared plus 1. G of X is 2X. Now, by definition, G of F of X is equal to G of F of X. But we know that F of X is X squared plus 1. So it's G of X squared plus 1. So it's 2 times x squared plus 1. So that means it's 2x squared plus 2. Right? So GOF of x is 2x squared plus 2. So again, if you want to compute GOF of 1, so it's what? 2 squared plus 2, sorry. It's 4, right? Or GOF of 3 is 2 times 18. Oh, sorry, 2 times 9 plus 2, 20. Now let's look at FOG. FOG could be different, the same F and G. So G of x is 2x, F of x is x squared plus 1. So let's begin with, again, x equal to 1. Then if G acts on x equal to 1, 2 times 1 is 2. And then immediately F acts, F takes 2 to what? 5. So that means FOG of 1 is equal to 5. So here FOG, I mean, in this picture, this is FOG basically. Yeah. So first G takes 1 to 2, F takes 2 to 5. That means G, FOG, when you combine them, they take 1 to 5. So you see it's different. GOF of 1 is 4. Or you can, let's say, let's do the same, x equal to 3. G takes 3 to 6. And then F takes 6 to 37. So FOG takes 3 to 37. FOG of 3 is 37. Again, you can find a formula for FOG. So by definition, FOG of x is equal to F of G of x. But G of x is 2x. So equal to F of 2x. F of 2x is 2x squared plus 1. So is equal to 4x squared plus 1. So FOG of x is 4x squared plus 1. Okay, so there are something interesting. Some interesting examples is, I mean, this is a very key example actually, is when you have inverse function, if you combine a function by its inverse, you get x identity. So let me tell you like this. So imagine that f of x equal to three x plus 1. What is its inverse of f? So you have to do in the opposite way. You multiply something by 3, add 1. That means you subtract 1, divide by 3, right? So the inverse of f is minus 1 over 3, right? This is basically the inverse of f. Now, what happens if you compose them? What is FOG of x? FOG is f of g, right? So it's f of x minus 1 over 3. So f of t, f of anything like t is 3 times t plus 1. So f of this is equal to, this is equal to 3 times x minus 1 over 3 plus 1. So this is x minus 1 plus 1, that is x. So you see that here, FOG of x is equal to x. GOF, if you also try, you will see GOF would be also equal to x. So that means if you compose a function by its inverse, you get x. The only thing you have to be careful is that, for example, we know that x squared and the square root of x are roughly inverse of each other's, x squared and root x. But the only thing is that x squared, because is not a one-to-one function, x squared. So it doesn't have actually as an inverse, really. It only has inverse if you restrict it to like positive numbers or negative numbers. So that means, so my point here is, if f of x equal to x squared and g of x equal to square root x, what is f of g of x or FOG of x? FOG of x is f of g of x. So it's f of square root of x. So it's a square root x squared, which is x. So FOG here is x. But the only thing you have to be careful is that the domain of FOG is all positive numbers here. The domain of FOG, because you have G first. You let G first act, and X cannot be negative in the square root. So the domain of FOG here all the x's that are greater than or equal to 0. How about g of f? G of f is different. G of f of x, because here first f acts. So it's g of x, g of f of x. So it's g of x squared. So because first f acts, then there is no restriction on x. So this would be equal to square root of x squared. Now, what is the square root of x squared? Who can tell this? No. Another price. I mean, you cannot have two values. It's a function. You cannot have two values. You say when you say positive and negative, that means you have two values. No. Square root of x squared. Let's say that x equal to -3. What is the square root of -3 squared? It's 3, right? So this is absolute value of x. Absolute value of x is not positive and negative x. It's x if x is positive, it's minus x if x is negative, right? So always remember, square root of x squared is absolute value of x. So that means here g of f of x is absolute value of x. But here the domain of g of f is all real numbers. I mean, for example, what is g of f of -2? So this is just square root of -2 squared, right? -2 squared is 4, so it's a square root of 4, which is 2. Or you can say it's just absolute value of -2, which is 2. So we also have this for exponential and ln of x. So if f of x equal to e to the power x and g of x equal to ln of x, then f of g of x is f of ln of x. So it's e to the power ln of x, which is x. But here, because first g acts, the domain of f of g is the domain of basically g. Because of the ln, because first you have to compute ln of x and then e to the power ln of x. And that means x must be positive. So FOG of X is identity. Identity means f of something is equal to itself. So f of x equal to x is identity function. Okay. How about g of f? G of f is g of f of x is g of e to the power x. But this is, now here the difference is you first have e to the power x, but e to the power x is already positive. That means for either x negative or positive, e to the power x is now positive. So ln has no problem, right? And this is equal to x, right? But the domain here of a g of f is all real numbers. Because first exponential function acts and e to the x is always positive. Then you take ln. So now here I give you an exercise. First, compute the inverse function f inverse, then show that f o f inverse of x equal to x and f inverse o f of x equal to x. So for this, f of x equal to 3x minus 5 divided by 2x. So first compute f inverse, then show that when you combine f with f inverse, you get f from two sides. Sorry, the second one is f inverse of f.
To go back to the previous page.
Yes. Okay, so here two important lesson is that you have to always to remember this. E to the power ln x is x, and ln of e to the power x is x. E to the power ln x is x, ln of e to the power x is x. The only difference here is that in the first equation, x is positive. Because ln cannot have negative numbers. But in the second equation, x can be negative. X can be anything. So here I want you to compute first f inverse, then show that f o f inverse equal to x, and f inverse o f is also equal to x. And then also part B, what is, I mean, let's first do this. I mean, that's fine, never mind. I won't bother you in another question. Everything's good? Okay, so I will continue tomorrow. So I will pause here.